Good day. I welcome you all at the lecture on the solving of a numerical problem by the application of strain energy under the subject Structural Analysis 1, and the subject code is CEPC 503 and the related module number is 3. Myself, Sandeepan Saha, Assistant Professor for the Department of Civil Engineering of Greater Kolkata College of Engineering and Management under JS Group. Let us first have a look on the topics that we are going to cover in this lecture. And the topics are that the numerical problem solving using strain energy method. By solving the following problem, we will be able to calculate the deflection at a certain point using strain energy method. And the problem is, here in this numerical problem, we have to determine the vertical deflection at point C in the given frame. That means we are talking about this frame and we have to calculate the deflection at this point, that is at point C of this frame. The data given to solve this problem is E, that means the modulus of elasticity is 200 kilonewton per millimeter square and the moment of inertia I is 30 into 10 to the power 6 millimeter to the power 4. Now we have to solve this problem. That means we have to calculate the deflection at point C. In this given frame, a load 1 kilonewton is acting at point C, whereas the distance between A and B, that means the distance between from this point to this point, the distance is 4 meter, and from B to C, that means from B to point C, the distance is 3 meter. In this frame, the moment of inertia for the member AB is 2I, whereas for member BC, the moment of inertia is I, and we have I equals to, that is moment of inertia equals to 30 into 10 to the power 6 millimeter to the power 4. Now we have to solve this numerical problem. That means we have to calculate the deflection at point C. That means we have to calculate del C. And to calculate this, we have to follow certain steps. And the steps are as follows. Step number 1 is determination of bending moment expressions for member AB and BC. Before further proceeding, let me remind you one thing, that here we will be calculating the vertical deflection at point C. That means here. In order to calculate the bending moment expression for the member BC, first let us put a section XX which is situated at a distance x from the point C, and we have the bending moment mx with respect to section xx equals to 1 into x, that means x. As the distance between force 1 kilonewton and the section xx is small x, so we get the bending moment mx equals to 1 into x, that is x, with respect to section xx. Following the same procedure, the bending moment expression for the member AB, we have mx equals to 3 kilonewton meter. Let us now have a look at the free body diagram of the given frame so that we can understand the calculation process of bending moment expressions for the member AB and BC. So, the free body diagram of the given frame is this one. So, this is the free body diagram of this given frame as per the problem we are dealing with right now. This is the free body diagram of the frame. This is the A point and this is the B point. This is the B point and this is the C point of the frame. In this free body diagram, you can see that this 3 kilonewton meter moment is generated due to the force 1 kilonewton acting at point C, as the distance between B and C point is 3 meter, and this 3 kilonewton meter moment is carried over to the AB member, and you can see it is working here. This is working here. So this 3 kilonewton meter moment is carried over to the AB member. In this regard, I should mention a certain point, that is, in order to calculate the bending moments, a section XX is taken at a distance x from the point C, and the bending moment calculations are done for the member BC and for the member AB. And based on the calculation we have done, this is the bending moment expression for the member BC, and this is the bending moment expression for the member AB. In this calculation table, here we have summarized the bending moment expressions what we have calculated so far. As you can see, for portion BC, the bending moment expression is x, and for the member AB, the bending moment expression is 3 kilonewton meter, and the limit for the integration process that we are going to do in the next step, the limit is for BC portion is 0 to 3, and for the member AB the limit is 0 to 4, whereas the origin, that means the calculation of origin for the BC portion is C, and the origin for the calculation of integration process for the member AB is B. The values that we have mentioned in this calculation table will be used to calculate the total strain energy. That means strain energy U equals to integration 0 to L m square by 2EI dx. So in the next step, the strain energy will be calculated using this formula. Using the data from this calculation table. So the next step is, that means the step number 2 is calculation of strain energy U using this formula. Putting the values from this calculation table into this formula, we get U equals to integration 0 to 3 x square by 2EI dx plus integration 0 to 4 3 square by 2e into 2I as the value of moment of inertia for the portion AB is 2I dx. This portion of the calculation deals with the calculation of strain energy for the member BC, and this portion of the calculation deals with the calculation of strain energy for the portion AB, whereas moment for the portion BC is x and moment for the portion AB is 3, and we get these values from this calculation table, and this total summation deals with the calculation of total strain energy for the entire frame. Upon further calculation, we get U equals to 13.5 by EI. That means the total strain energy for the entire frame is U equals to, that means the strain energy equals to 13.5 by EI. Now the work done by this applied load is equals to, that means work done is equals to half into the applied load 1 into the deflection caused by this the applied load. So this is the total work done by the applied load. Now equating work done and the strain energy, we have work done equals to total strain energy. That means half into 1 into delta. That means the value of work done is equals to the total strain energy U. That means equals to 13.5 by EI, which is the total strain energy. And from this calculation, we get del equals to 27 by EI. So the vertical deflection at point C is equals to del C, that means 27 by EI, whereas as per the given numerical problem, we have E modulus of elasticity equals to 200 kilonewton per millimeter square, and the moment of inertia I equals to 30 into 10 to the power 6 millimeter to the power 4, and putting the values of E and I here, we have del, that means deflection at C equals to 4.5 millimeter. So based on the calculation, we get vertical deflection at point C, that means del C is equals to 4.5 millimeter. Thank you.